Hey, welcome back. We have a video here on finding rational zeros. And in order to understand finding rational zeros, you have to understand what the word rational means. So a lot of times when I think of rational, I think of ratio. And ratio is when you can make a fraction. So finding rational zeros. Rational number is a repeating or a terminating decimal. If we look here, 1/2 is a terminating decimal, 0.5. It stops, it terminates. 5, well, you may think that 5 is not necessarily a fraction, but remember it's over 1, and that's a terminating decimal. -10 is the same way. You can have negative numbers in it. And -1/3 is a repeating decimal. It's -0.3 repeating. Okay, that's what rational numbers are. Now we're looking at integers, because the next, the theorem I'm going to have up on the next slide talks about integers. And remember, just integers are just whole numbers, positive and negative, and the number 0. There are no fractional parts. So -1/2 is not an integer. Remember that integers are rational numbers, though. Okay, here's the rational zero theorem, and it may get a little messy in here, but remember that I will show you numerous examples here. So, if f of x is equal to a sub n times x to the nth power plus, and we're working that all the way down to a sub 1, x to the, remember that's the first power, and plus a sub 0. A sub 0 is just a constant. Okay, so if we have a function here, and it has integer coefficients, and we know what integer is because we just talked about that on the last line. Coefficients are going to be the numbers in front of the variables. Then every rational zero, we just talked about rational zero, then every rational zero of f has the following form, p over q. And we've dealt with p and q in other places, but what's p and q going to be? P is the factor of the constant term, a sub 0. So that's p. It's always the factors of that last number out there without a variable. And q on bottom is going to be the factor of the leading coefficient right here, a sub n. Okie dokie. So let's put this to use so that way you can understand what this is. This is some math talk, but let's go ahead and put this to use. Remember that when we are looking for zeros, roots, or solutions, we're trying to find out where the graph crosses the x-axis. And that's what we're trying to do here. We're trying to figure out where the graph of these functions cross the x-axis. Remember, you can always throw these into a graphing calculator and graph them real quick and come up close, or you can plug in a table of values and graph them and try to come up with the solutions there. But this is how we can find them using just using some work. All right, so we know that Q is going to be, I said that wrong. P is going to be the factors of 12. All right, so what are factors of 12? Well, the factors of 12, about 1 times 12. So 1, 12. What else? 3 and 4, 2 and 6. Now, those are all positive numbers. But what about negative numbers? So basically, all of these will have a positive and negative, because I know 3 and 4 is a factor of 12, but what about -3 and -4? So instead of writing it twice, instead of putting +3 and then -3 later on, I'm just going to put plus and minus. every single one of them. Okay. So those are the factors of P, the constant term out there at the end. And now let's look at the factors of Q. Factors of Q is the leading coefficient, which that one is pretty easy, right? That would be 1 times 1, which is 1, or negative 1 times negative 1, so plus or minus 1. Hey, that's pretty simple there. All right, so we have just kind of come up with those factors. Now what we have to do is we have to make a list of all possible zeros. All possible zeros. The rational zero theorem said that the functions will have zeros in the form of P over Q. But it didn't say every single one of them was going to be a zero, a solution to it. So P over Q, let's just start. You're always going to either have 1 or negative 1 on the bottom. So start here. We're going to have 1 over 1. And that's going to be plus or minus. And it doesn't matter which combination. If we choose positive, negative, we're covered here with the negative. If we choose negative, negative, we're covered with the positive. If we choose positive, positive, we're covered with the positive, and negative, positive, we're covered with the negative. So basically, as long as we just worry about 1 and 1, making those into a fraction, and then putting plus minus in front of all the fractions. So 12 and 1, 3 and 1, and 4 and 1. Then there's 2 and 1, and 6 and 1. So right now you've just identified all of the possible zeros. I hope you have enough number sense in your math toolbox there to realize that instead of writing it out like this, you could have written plus or minus 1, plus or minus 12, plus or minus 3, plus or minus 4, because 1 over 1 is 1, 12 over 1 is 12, and so forth. I hope you would have realized that. Okay, so where do we go from here? Well, from here, we just go ahead and plug in some values. So we're just going to pick any number, and then we will plug it into synthetic division there. So any preference? No preference? Okie dokie. Let's just start with, I'm erasing some of this. Let's just go ahead and start with 1. Okay, so now that we have our possible zeros, you'll want to keep that on your paper. And I'm going to put possibilities here. What do we have? 1, 2, 3, 4, 6, and 12. And remember, plus or minus for all of them. So let's go with 1. That's supposed to be x squared. I'm just randomly picking this one here. So let's let x equal 1. All right, drop down. There's the 1. 1 times 1 is 1. Go ahead and add those. You get negative 1. 1 times negative 1 should be negative 1. Add those, we get negative 12. 1 times negative 12 is negative 12. And add these two, you get 0. And this is what we're looking for. We're looking to get a 0 there, which then would make us having a this as a 0. So we know that the graph will cross at positive 1. So actually, I don't want to do this. I want to just put zeros here. That way we know zeros. So we know 1 is a solution. And since there is a third degree polynomial here, we know there should probably be 3 zeros. Some of those may be irrational or complex numbers, but we should still be able to go through the list and figure out which ones are possible, or which ones are actually rational zeros. So far we're good to go. We got 1. Now, we could take the next one, which is -1, and we could plug -1 in here and work it out to see if it fits. I think I just created a word there. Drop down your 1. -1 times 1 is -1. There's -3. -1 times -3 is +3. Combine those two, you get -8. -1 times -8 should be a +8. And combine, you should get 20. And we know that -1 is not a 0, because we're looking to get 0 at the very end. We're looking to have nothing left over. Okay, so where are we at then? We can just keep picking numbers and plugging them in, or let's go back there in your notes and watch this part where x was 1. So we're here, and we were able to find that x was equal to 1. But now, let's look at this here. This should be, let's see, if this was x cubed, it should be 1x squared minus 1x minus 12. And so, in synthetic division here, we know p is 1, and 12, I'm sorry, q is 1, 12 is your p. I keep getting those mixed up because the 1 comes first and p comes first in the alphabet. But anyways, so let's figure out possible zeros here. So for -12, for p, we could have 1, 2, 3, 4, 6, and 12, which happens to be the same thing that we had before with +12. So then which one's a solution here? Well, we keep checking. I can tell you, though, that if I have x squared minus 12, can't we pick 2 numbers that multiply to give you -12 that add up to give you -1? 2 numbers multiplied to give you -12 are -4 and 3, which adds up to give you -1. And so therefore, we can split this up into x minus 4, x plus 3. And we can factor that out. The other one, x was +1, so the factor is going to be x minus 1. So finding all rational zeros here, x would equal 1, x would equal 4. Remember, we set each one of these equal to 0. And x would equal -3. So anytime that you can get down here and factor, or anytime that you can get a new set of possible zeros, you'll want to do so. It's a lot of steps. Follow the process. You have to remember how to factor and use your factoring skills when you can get there. Okay, let's look at this next one here. Find the rational zeros of all of those numbers. Or I'm sorry, not those numbers, that function. So let's go p over q. So p is going to be all the factors of 12. 1, 2, 3, 4, 6, and 12. What are all the factors? This is Q. What are all the factors of 2? Well, it's 2 and 1. So here's 2, here's 2, 2. So we're putting the factor 2 below everything. And then we also have to put the factor 1 below everything. So we kind of got to have 2 lists here. And do I need to put 1 underneath all of these numbers here? All of these numbers in this list? If I put 1 under them, they still get to be the same numbers. So as I'm looking here, these numbers, there's quite a bit of them there. There's what, 6 of them down here at the bottom. And how many are at the top? Well, plus or minus 1/2. Well, 2 over 2 is just 1. We have it down in the bottom list, right there. 3/2, okay. 4 over 2 is 2. We also have it right there. 6 over 2 is 3. We have it right there. And 12 over 2 is 6. We have it right there. So really, in the top list, all we have left is positive negative 1/2 and positive negative 3 over 2. And so this is the list of our possible zeros. And remember, this is only possible zeros. This is not all of the zeros, because now we have to pick one of these and try to figure out which one is the actual 0. You could start off picking any number you want. Let's go ahead and start off by picking 1. So for x equals 1, let's do synthetic division here. We're going to have 2, negative 3, negative 23, and positive 12. And synthetic division. So we drop down the 2. 1 times 2 is 2. Add them together, negative 1. 1 times negative 1 is negative 1. Add them together, negative 24. And 1 times negative 24 is negative 24. Add them together, negative 12. That number does not equal 0, so we know positive 1 is not a 0 of this function. Positive 1 is not a 0 of that function. Okay. Let's go ahead and try negative 1 then. Negative 1 just changes a few things here. Negative 1 times positive 2 is negative 2. We get negative 5. And then that makes this positive 5. Add them together, negative 18. Negative 1 times negative 18 should be a positive 18, which then leaves us with 30. And we are just striking out. Okay, well, let's move on. And we could keep going on that list if we wanted. Considering we have, what, 2, 4, 6, 8, 10, 12, 14 more choices to go. 14 more choices to go. Let me show you something that we could use here. Let's go to example number 2, and let's graph it. Get rid of this. So let's go ahead and graph y equals 2x cubed minus 3x squared minus 23x plus 12. Okay, so let's zoom out. When we zoom out far enough, we can see what this graph is actually doing here. And here's what it looks like. Remember, we're zoomed out to negative 40 and 80 out here. But what we're worried about is the zeros. And as we scroll in, it looks like negative 3 is one of them. It looks like positive 4 is another. And here's the origin, 0, 0. Right here is a rational 0. So go back to our possible list. We have positive negative 1/2. Well, we know it's a positive number because it's to the right of the origin. So it's either positive 1/2 or positive 3/2, and it looks like it's going to be positive 1/2. Positive 1/2. So by graphing it, you can quickly find those rational zeros approximately where they're at. This one is pretty easy as far as it's actually crossing right there exactly. So we said positive 1/2. I mean, we could have kept going through the list, and we could have kept going through the list and trying to figure everything out. But let's just go ahead and try. Positive 1/2. 2, negative 3, negative 23, and positive 12. So positive 1/2. So we drop 2. 1/2 times 2 is 1. Add those together. Negative 3 plus 1 is negative 2. 1/2 times negative 2 is negative 1. Add negative 23 and negative 1 together to get negative 24. 1/2 times negative 24 is going to be negative 12. Add those together. That leaves us with a 0. And that's what we're looking for. We're looking for x equals positive 1/2. X equals positive 1/2. And so this was to the third power, so x squared, x, and negative 24 is what we have here for the next factor. I know I can factor out a 2 out of everything. And here we go. Can you give me two numbers that multiply to give you negative 12 and add up to give you negative 1? Two numbers multiplied to give you negative 12 is going to be negative 4 and positive 3, and that adds up to give you negative 1. And so all of our factors, even bringing this one down here, this is going to be a 2. The 2 comes out front. And this is from here, we have x minus 1/2. And here we're going to have x minus 4. And then we're going to have x plus 3. And we have completely factored down this up here, this function up there. Granted, they may want you to distribute this one here to be 2x minus 1. And then x minus 4. Now this factoring part is not necessarily part of what we're showing you at this moment. It's kind of part of the process that you should be thinking. We need to be finding out what the x's are. We already know one of them is 1/2. And what's the other two? Well, set this equal to 0. What does x equal? It equals positive 4. And set x plus 3 equal to 0. And what does x equal? Negative 3. And so therefore you have your three rational roots. 1/2, 4, and negative 3. Okay, this one here. Let's see if you can work this one out on your own. When you get done, hit play and watch my solution here. So go ahead and pause the video and work it out on your own. All right, I'm looking. I know possible zeros are going to be, let's see, what do we have? We have 1 and 2, and here we're going to have 1 and 3. So 2 over 1, 2 over 3, and of course positive and negative for all of them. And then we're going to have 1 over 1 and 1 over 3. And so possible zeros, here's a 2, here's a 1. I'm going to try 1 first, just because I like working with 1. Seems to go a little bit smoother than trying to work with some fractions. Although you should know how to work with fractions. So I'm choosing 1. 1 times 3 then becomes 3. Combine these, we get -2. We get -2 here, -7, -7, and -2, and -2 here, and 0. So we picked right. 1 is a possible choice. Now from here, I could say that this was 3x to the third power minus 2x squared minus 7x minus 2 and try to factor that down. But remember, this is still x to the third power, and there's no simple way of factoring other than finding possible zeros. But let's go ahead and look at possible zeros here. -2, +3, which is the same thing that we had up here. And so our possible zeros are still the same. So instead of trying to break that down into 3x cubed minus 2x squared minus 7x minus 2, I'm just going to pick a different possible zero and try to find it. Just try to get lucky here and try to find it. I also could graph it and see. Let me try one more. I can try -1, and let's see if that doesn't make things, let's see if that doesn't work here. So where are we at? -8. Let's see, this is +8, +3, this is -3, this is 2, and this is -2, which is 0. We found another one. So the other one is going to be -1. And then so from here, since we know -1 is a solution, and like I said, I could be graphing these and finding the other two. I know -1 is a solution. I also know 1 is a solution. So let me break this down, because I don't want 3x squared or 3x cubed. I want x squared so I can factor quickly. So let me go ahead and break this down here. Do synthetic division to figure out what we have. -2, this is -2, and this is 0. Okay. Got something sweet here. So we have 3x squared minus 5x minus 2. Looky, looky. We have an x squared. Now remember, I had to do synthetic division twice because we had x to the 4th power. The function was x to the 4th to begin with. And now I want to break it down to this. So since a is 3, it's not as simple as if a was 1. So if we look here, I need two numbers that multiply to give me -6 that add up to give me -5. Is that -6 and +1? That's true, -6 and +1. So that's 3x squared minus 6x plus x minus 2. And I'm just factoring by grouping here. I'm going to factor out 3x, and that leaves me x minus 2. I'm going to factor out nothing out of here except a +1. And I don't need to put the +1 there because I know it's in there. X minus 2. Look at my parentheses. They are the same. And that's what I'm looking for. And what's in front of the parentheses goes in the second one. Okie dokie. Set this equal to 0. What's x equal to? 2. And set this equal to 0. What's x equal to? Well, -1. So that means 3x is equal to -1 divided by 3. -1/3. Wow. Okay. Kind of got intense there a little bit. I know I went pretty quickly, but remember, this is something you should already know how to do. Using a lot of the skills, you should already know how to factor. And so if anything here catches you up, try to put a mark on it on your paper. And next time you see me, you can ask me, or you can just call in to our daily show. We air live every day, 2 p.m. on, I forget, Channel 12. Channel 12, that's it. Yes, Channel 12. Okie dokie. You can graph this function and check to make sure your zeros are correct. Remember, these are rational zeros. I bet you in the next video is how to find all zeros. We'll see. Okie dokie. Well, I appreciate your time, and we will see you on the next trip.